Hi guys, and this is our problem one on comprehensive topics of counting. And here is our first problem. Contestants A and B are competing in an alien chess tournament. So I wonder how they play it. There is no draws, meaning that there is always a winning side and a losing side. By the time one side wins 3 more matches than the opponent, that side will win the tournament. If after 11 matches A has won the tournament with 7 matches won and 4 matches lost, how many different combinations of matches satisfies these pieces of information? So here, what we can do is create a grid. A grid, you might ask? Well, yes, a grid to help us visually show this entire situation. So when I make it, you'll get what I mean. All right, because we know that there are four matches lost and 7 won, I'm going to make a rectangular grid. What that is 4 by 7. Let me explain to you how this system is going to work. So every single time A loses, we are going to have an imaginary point stay in that same place, one grid. But if A loses, it means that B wins. So if B wins a match at that same time, we're going to move it up 1 on the y-axis. But whenever A wins, then we're going to move it right 1 on the x-axis. So here is my grid. After we enlarge it, we will see that it's 4 by 7. And every single time B wins, we move up. Every single time A wins, the point moves right. But what if it comes to here? Would this point be a possibility for would this section be this point here be possible for a dot to move to? No, because here A would have already won, right? Because this is when A has won 3 more matches than B, with B winning no matches and A winning 3. So A here, say this is the starting point and this is the finish line. This point is going to represent A and B's losses and gains. So every single time B wins, we move up. A wins, we move right, and we're trying to get this dot to here. And now also, because this point is not possible, now there's this one, so I'm going to cut this out to show that, and we're going to have these points will not work as well because it just means that B has already won 3 more than A. So these sections are not possible, neither are these sections. All right. So here we have our first point. This intersection right here for A. Well, how many possibilities can we land on this point? 1, right? Because this is our starting point. How many? And now we're just going to keep doing this until we get to the final point. How many possibilities will we land here? Well, in order to land here, we have to come from the starting point, right? It's always here to here. There's no such thing as going up and then back down. It's always moving left, right, top, right. So here we have 1 possibility of getting it, this as well. So all of these on the sides will have 1 chance of getting there. Now what about this point? It's not on the side. You can think of it as in between, like a tilted V between 2 ones. So in order to get to this point, we could go this direction or we could go this direction, all starting from a starting point, S. So here we have 2 possibilities of getting there. Now 2 and 1, this is their intersection. If we follow the pattern, this is 3 and this is 3. 3 and 3, we have 3 and 3, we have 6. And because we have 3 here, but there's no other one on this other side, right? Because this is not a possible point to be at. Here we just have 3 again. We just repeat the one it's connected to. So this becomes 9, and this becomes 9 as well. Now moving down. This is not in between any 2 points. It's just connected to 1 point, which is the 3, because this point is not possible to be at. Again, we just carry the 3 over. 6 plus 3 is 9, so this is also another point with 9. This has 18, so now we can see that this point is in between 9 and 18. Add that, we have 7, 27. Which means that this point here is also 9, right? Because this point is between this one and this one, except that this one, the bottom one, is not possible to be at, so we just carry the 9 over. 18 plus 9 is 27. 27 plus 27 is 54. Now we keep continuing like this. This would also be 27 until, we just keep carrying over, and our final point is 81. So final answer is 81.